Yeah, guys, very good morning to all of you. Are you able to hear me? Okay, in previous class, we were discussing about the EDM, electronic distance measurement and curve setting. Okay, now, and before that, we have also been discussed about the tacheometric surveying. Understand? I know. So these are the three concepts we are having in Unit 4. Okay, now, so coming to tacheometric surveying, what do you mean by tacheometric surveying? Can anybody tell me? What do you mean by tacheometric surveying? I'm asking. Or tell me, at least tell me what is tachometer. All of you raise your hand. All of you raise your hand. I'm audible to all of you now. So then answer. Anyone can answer. I'm not specifically asking. Okay now. Anybody can answer. What is tachometry or tachometric survey? Or tell me at least what is tachometer. Okay, tachometry or tachometric survey is nothing but the survey what we do by using the instrument tachometer. Okay, now so the main objective of tachometric survey is to determine the horizontal distances as well as vertical elevations of objects on the earth surface wherever linear measurements or angular measurements are not possible, or wherever we do face many number of difficulties or many number of obstacles. In that case, the tachometric survey will be used to measure or to determine the horizontal distances as well as vertical elevations or vertical distances or elevations of the objects. Okay now, so this is simply we can call tachometry or tachometric survey. Okay now, and for that, tell me. And simply the what you call the instruments will be used for tachometric survey are, one is the tachometer will be used. Okay now, tachometer will be used, and another one is leveling staff will be used. Okay now, so basically two types of instruments will be used. One is the tachometer and another one is the leveling staff, and tripod will be used to set up, it means that to set up the tachometer. Okay now, so tachometer and leveling staff will be used for measuring the distances as well as elevations in tachometric survey. Okay now, and also we have seen two formula. Okay now, so in tachometric survey, two kinds of methods are there. One is the steady diaphragm method and another one is the tangential method. Okay now, so in steady diaphragm method, instead of using ordinary or normal diaphragm, we will use a special diaphragm. It will be called as the steady diaphragm. Okay now, so whenever we use diaphragm inside a telescope, it will be called as the theodolite. Okay now, and whenever we use steady diaphragm inside a telescope, it will be called as the tachometer. Okay now, so that is the difference between theodolite and tachometer. Okay now, in theodolite, in diaphragm will be used. In the diaphragm, only two crosshair will be there, one vertical crosshair and one horizontal crosshair will be there. Okay now, and if you take tachometer, in that it means that two more additional crosshair will be there. Okay now, so if you take horizontally, in horizontal, top crosshair will be there, middle crosshair will be there, as well as bottom crosshair will be there. It means that three crosshair will be there. Okay now, only that is the difference between tachometer and theodolite. Okay now, that's all. And in this case, wherever you want to measure the distance or wherever you want to measure the elevation of the object, at that point we keep the leveling staff, and then at the leveling staff we will take three readings on the leveling staff, as well as till that point we will measure vertical angle. That's all. These are the measurements what we take in case of tachometric survey. Okay now, so two kinds of two measurements will be taken on leveling staff. Okay now, So one is the reading on the leveling staff will be taken which are coinciding to the three crosshairs. Okay, it means that on leveling staff we will get top reading, middle reading and bottom reading. Three readings we will take on leveling staff, and one more thing, to the leveling staff we will take the vertical angle. We do take the vertical angle. Okay, now so these are the measurements what we take in case of tacheometric survey. Understand or no? And after taking the measurements, what we will do, or after taking the readings, what we will do, we will calculate the horizontal distances as well as vertical elevations of the objects. Okay, now so the horizontal distance can be calculated by using the formula d is equal to ks cos square theta plus c cos theta. Okay, now and the vertical distance or vertical elevation of the object can be calculated by using the formula ks sin 2 theta divided by 2 plus c sin theta. Understand or no? Okay, now by using these two formula, we can determine the horizontal distance as well as vertical distance or vertical elevation of the objects. That's all. This is about the study method in tacheometric survey. Okay, and one more method is that is tangential method. Okay, now so after completing this, we do discuss about the tangential method of tacheometric survey. Okay, now in study method on leveling staff, we take three readings: top reading, middle reading, and bottom reading. Okay, now, but in case of tangential method, we don't take middle reading. We take only two readings: top reading and bottom reading. That's all. That is the difference between stadia method and tangential method. Okay, now so first we do discuss about the stadia method of tacheometry, and then we will discuss about the tangential method of tacheometry. Okay, now I think now it is clear to all of you what is the tacheometric survey and what is stadia method. Okay, now so still if you have any doubts you can ask me. Any doubts? Okay, and now I am going to solve one problem on tacheometric survey. Okay, now. See guys, the screen is visible to you or no? Screen is visible or no?
Yes, sir.
Yeah, okay.
Visible.
Hmm. Okay, from this figure you can understand. Okay, now so basically the tacheometric survey will be used to determine the horizontal distance as well as vertical distance or elevation of the objects. Okay, now so in this case you can see here one instrument station is there, one object station is there. Okay, now so where from the instrument station is at lower level and the object station is at higher level. Understand or not? So and P it is the point. It means that it may be what we call benchmark. Understand or not? So benchmark will be there. Benchmark is used to know the height of the instrument or reduce level of the instrumental axis. Okay, now so for that it will be used. Okay, anyhow, D is the horizontal distance between the instrument station as well as object station Q. Okay, now and V is the vertical distance from instrument axis to the object. Understand or not? So that's all. And to determine the D, this is the formula. D is equal to Ks cos square theta plus C cos theta. And to determine V, this is the formula. V is equal to Ks sin 2 theta plus C sin theta. Okay, now so this is the formula. And one D from the instrument to the object, the horizontal distance on the surface we can determine by using the formula, and as well as the from the instrument axis to the object, V is the formula to determine that. Okay, now and where K is the multiplying constant, always remember that the K is the multiplying constant and the value of K will be equal to 100. In most of the cases K value will be 100. Okay, now if not given in problem K value, directly you can take it as 100. Okay, now and S, what is S here? What is S here? S is the stadia intercept. Okay, now already we have been discussed it. S is the stadia intercept. Okay, now so stadia intercept means in leveling staff we will take three readings now: top reading, middle reading, and bottom reading. Okay, now so the difference between the top reading and the bottom reading will be the S. It means that stadia intercept. Okay, and theta is the vertical angle. Whatever we take from instrument to the object, vertical angle. Okay, now so theta is the vertical angle here. Understand now? And C is the, what is C here? You can see C is here now. That C is nothing but additive constant of the instrument. And remember that always the additive constant of the instrument C value will be equal to 0. Okay now, so write down that again. I am writing here where K is the multiplying constant. All of you take notes. All of you write down multiplying constant of the instrument, and most of the cases K value will be equal to 100. Okay now, and where C is equal, it will be small c. Okay now, C is equal additive constant. The additive constant value will be equal to 0. Okay now, and where S is the, what is S? I told you, S is the stadia intercept. Stadia intercept. Okay now, and it is the difference between the top reading and bottom reading. Okay now, so top reading on leveling staff minus bottom reading on leveling staff will give you the S value. Understand now? So that's all. And where theta is the vertical angle. Understand now? You can take it as theta. Theta is equal to vertical angle. Okay now. So by using this formula, D is the formula for measuring the horizontal distance. Okay now. And V is the formula for measuring the vertical elevation of the objects. Okay now. And K is the multiplying constant, its value equal to 100. C is the additive constant, its value equal to 0. And S is the stadia intercept. It can be taken by the top reading and minus reading. Sorry, top reading minus bottom reading on the leveling staff. And E theta is the vertical angle. It is given here. Okay. And our ultimate objective is that here to measure the reduced level or RL. RL of the object we have to measure here. Okay. Now how do you determine the RL of the object? RL of the object can be determined by using the benchmark plus height of the instrument. Okay now, plus V. Understand? So plus V minus central reading on the leveling staff or middle reading on the leveling staff. Okay now, central, or you can write it as middle reading on the leveling staff. Okay now, so at the end of our problem we have to determine the RL of the object station. Okay now, so this is our most important concept, most important thing. Okay now, so I think that all the things are visible to all of you. Okay now. K is the multiplying constant equal to 100. C is the additive constant equal to 0. S is the stadia intercept top reading minus bottom reading. Theta is the vertical angle. And RL of the object we have to determine, that is can be calculated by using the benchmark plus height of the instrument plus V minus middle reading. That's all. First we have to calculate the D here, and next we have to calculate the V here, and at the last we have to calculate the RL of the object. These three things we have to calculate in each case. Okay now, I think guys it is to all of you it is understand. Okay now, so all of you take the problem number 1 now. First problem. I think first problem it is visible to all of you. Is it visible to all of you or no? Okay now, solution I'm writing. First read the problem here. The elevation of a point P is to be determined by observations from station A of a tacheometric survey. Okay now. So the staff was held vertically upon the point and the instrument is fitted within the analytic lens. The constant of the instrument being 100 and 0. Compute the elevation of point P from the following data considering the observations. Okay now. So from this what you are understanding? P is the object point or object station. Okay, and at P, if it is the P is the object station, what we have to do? We have to place a leveling staff at P. Okay, now if P is the object point, we have to place a leveling staff at P. Okay, and then and A is the instrument station. Instrument means tachometer. Okay, now A is the instrument station. It means that A is the point where we kept the or where we set up the instrument. Okay, now so at A we set up the instrument and at P we set up the leveling staff, and our aim is, what is our aim here? Compute the elevation of the point P. Okay, now see here, our aim is to determine the elevation of point P. We have to determine elevation of point P. Okay, and also we have to determine the distance between A and P. Okay, now so these are the two things we have to determine: elevation of point P we have to determine, and distance between A and P we have to determine. Okay, now and remember that A is the instrument station and P is the staff station, and from A we do take the measurements or readings, and at P we keep the leveling staff, and the height of the P or the elevation of the P we have to determine. Okay, now and you can see a vertical angle has been given here, 2 degrees, sorry, it is 2 degrees 24 minutes. Okay, now vertical angle is 2 degrees 24 minutes. It is been given here. Okay, now so take the, see the table here. Instrument station is A, given height of the axis is given as 1.42, and staff point is given as P, and vertical angle from A to P is given as 2 degrees 24 minutes, and staff readings at P were given as 2.230, 2.055, 2.880. Okay, now so in this case the top reading will be 2.880 and the bottom reading will be 2.230 and the middle reading will be 2.055. Okay, and RL of the instrument station is given as 77.750 is given here. Okay, now so these are the what you call different things they have been given. Okay, now and write down that this is the table is given here. Okay, now so our aim is that two things we have to determine here. Okay, now so what are the things we required here? Our required things are, one, what is our first required thing? Elevation of P. Elevation of P we have to determine here. Okay, now and the next what we have to determine? Distance between A and P we have to determine. Okay, and the next at the end we have to definitely we have to determine the RL of P. Okay, now these three things we have to determine here. Okay, now so elevation of P means, what do you mean by elevation of P? చెప్పండి. What is elevation of P, or what is the formula for elevation of P? We have seen V is the elevation of P. It means that V, this is the formula we have to use to measure the elevation of P. Okay, now so take the formula. V is equal to sine 2 theta divided by 2 plus C sine theta. Okay, now so first of all, this is the formula to measure the elevation of P. I'm copying the formula here. Okay, now and I will determine V is equal to V is equal, what is K is given? K is the multiplying constant. What is K? We have to take always K value, always we have to take it as 100. Yeah, guys, tell me. Anas. Sheikh Anas. Okay, Sheikh Anas, I think your roll number is 138. What is your roll number? Sheikh Anas. Please, I request you all to join through the official login ID. Okay, now so don't join through somewhere else. Don't join as a guest. Okay, already 21 series 112 joined as guest. Okay, and 108 also joined as guest. Lateral 108. Okay, now okay. But if you join through official login ID, it will be good. Okay. K is the multiplying constant. Always the K value will be taken as 100. Okay, now 100 into S. What is S here? Steady intercept means S.
1.65.
Yeah, S value can be taken as S is equal top reading minus bottom reading. Okay, now so what is the top reading here? Staff reading 2.880.
2.880
Uh,
minus 1.230.
that is equal to
1.65.
1.65.
50.
1.650. Okay, na? Okay, S value can be taken it as
1.650.
hmm, S value can be taken as 1.650. Okay, na? And into sine 2 theta.
Sine 2 into 2 degrees 24 minutes.
Hmm. Vertical angle here it is given as theta is equal to 2 degrees 24 minutes. Okay, na? Sine 2 into
2 degrees 24 minutes.
yes. Okay, here the in MS Word the degrees and minutes may not come here. Okay, na? So you can take it as 2 degrees 24 minutes. Okay, na? And 2 plus C 9
0. 0 into
2 degrees 24 minutes.
C equal to 0.
V equal how much is coming? V equal to calculator, tell me. It has 2d 24 m means 2 degrees 24 minutes. Like that you can take it here. Okay, now 2 into 2 degrees 24 minutes divided by 2 plus sine C sine
6.90.
6.90. Yes, 6.90 3 meters it will come.
3.
V value will come it as 6.903 meters. Okay, now here I am writing the S value. Okay, so this is the elevation of P we have been calculated. Okay, now next we have to calculate the distance between A and P. Okay, now so it can be calculated by using the formula D is equal to C ks cos square theta plus C cos theta. That is the formula for D. Okay, now I'm taking the formula. And we know where D is equal to K means 100. Okay, now into S means 1.650 into cos square Okay now. So theta means, what is theta here? 2 degrees 24 minutes plus c means 0. Okay now. Leave it. C అంటే 0 కదా, 0 into cos 24 degrees 2 degrees 24 minutes. Okay now. Okay, calculate and tell me the d value.
164.71, sir.
164 point
71 meters.
yes, correct. 164.71 meters. Okay, so that is the d value we got. Okay now, so d is equal 164.71 meters. We calculated. Okay now, so next RL of P we have to calculate. Okay now, so what is RL of P here? This is the formula. RL of object or RL of P is equal benchmark plus RL of the object, sorry, benchmark plus height of the instrument plus V minus middle reading on the leveling stuff which is kept at the object. Okay now. That is equal to benchmark plus benchmark, it is given here. RL of the instrument directly it is given here. Okay now, so RL of the instrument it is given as, it means that the instrument station itself they have been taken as the benchmark there. Okay now, so RL of the instrument they have been given as 77.750. Okay now, so write down here 77.750 plus height of the instrument, how much they have been given here? 1.42 will be the height of the axis of also height of the instrument. Okay now, so 1.42 plus V here, say 164.71, 164.71 minus what is the middle reading given? What is the middle reading given?
Sir, V 6.903, sir.
V is the 6.903 or 902. Okay, 1 or 2 decimal ఏం కాదులే, nothing will happen. Okay now.
Kinda 164.71.
Acha, V value how much you got? 6.903.
6.903.
Okay. 6.903 or 902 minus middle reading is the 2.055. 2.055.
84.018.
84.01. 84.01 meters. This is the RL of the object station. Okay now, so that's all. These three things we have to calculate anyhow, anytime if they give problem at tacheometric survey, these three things we have to determine. First we have to determine the V value, D value, and then RL of the object. Okay now, so formula for V is the V is equal to Ks sin 2 theta divided by 2 plus C sin theta, and formula for D is the Ks cos square theta plus C cos theta, and formula for RL of the object is the benchmark plus height of the instrument plus V, it means that elevation of the object minus middle reading. That's all. Okay now, so this, like this we have to solve problems. Okay, we can take second problem.
Sir,
చెప్పండి.
అదే హైట్ ఆఫ్ ఇన్స్ట్రుమెంట్ ప్లస్ బెంచ్ మార్క్ ఈక్వల్ టు RL కదా సార్?
హైట్ ఆఫ్ ద ఇన్స్ట్రుమెంట్ ప్లస్
బెంచ్ మార్క్ ఈక్వల్ టు RL కదా సార్?
అవును.
అయితే మనం ఇక్కడ ఆల్రెడీ RL ఇచ్చినప్పుడు మనం
ఆర్ఎల్ ఆఫ్ ద
డైరెక్ట్
ఇన్స్ట్రుమెంట్ స్టేషన్
RL
ఇచ్చింది.
ప్లస్
ఇన్స్ట్రుమెంట్ యాక్సెస్ కాదు, ఇన్స్ట్రుమెంట్ స్టేషనే కదా మనకి ఇచ్చింది. అర్థమైందా?
మనం బెంచ్ మార్క్ ప్లస్ హైట్ ఆఫ్ యాక్సిస్ రెండు కలుపుకొని RL ఇది అనుకుంటారు కదా సార్?
ఎప్పుడైనా సరే మనకి బెంచ్ మార్క్ ఇస్తాడు. బెంచ్ మార్క్ దగ్గర మనం ఏం చేస్తాం చెప్పండి, అంటే బ్యాక్ సైడ్ టాకోమెట్రిక్ కానీ ట్రిగ్నోమెట్రిక్ లెవెలింగ్ కానీ చేసేటప్పుడు జస్ట్ ఇన్స్ట్రుమెంట్కి జస్ట్ 1 or 2 feet బ్యాక్ సైడ్ మనం ఏం చేస్తాం చెప్పండి, లెవెలింగ్ స్టాఫ్ ప్లేస్ చేసి బ్యాక్ సైడ్ తీసుకుంటాం. ఓకేనా? సో బెంచ్ మార్క్ ప్లస్ స్టాఫ్ రీడింగ్ అంటే ఏమవుతుంది మనకి, బ్యాక్ సైడ్ రీడింగ్ అంటే హైట్ ఆఫ్ ద ఇన్స్ట్రుమెంట్ అవుతుంది. ఓకేనా? సో బెంచ్ మార్క్ ప్లస్ హైట్ ఆఫ్ ద ఇన్స్ట్రుమెంట్ మనకి ఆర్ఎల్ ఆఫ్ ద ఇన్స్ట్రుమెంట్ యాక్సెస్ అవుతుంది. ఓకేనా? సో ఇక్కడ ఏం చేసిందంటే ఆర్ఎల్ ఆఫ్ ద ఇన్స్ట్రుమెంట్ స్టేషన్ ఇచ్చిండు, హైట్ ఆఫ్ ద యాక్సెస్ ఇచ్చిండు. అంటే టెలిస్కోప్ సెంటర్ పాయింట్ ఆఫ్ ద టెలిస్కోపే మనకి హైట్ ఆఫ్ ద యాక్సెస్ అవుతుంది. ఓకేనా? సో ఆర్ఎల్ ఆఫ్ ద ఇన్స్ట్రుమెంట్ ప్లస్ ఆ 1.42 meters కలిపితేనే మనకి ఆర్ఎల్ ఆఫ్ ద యాక్సెస్ అవుతుంది. ఓకేనా? మనకి వి వాల్యూ అంటే
మనం
చెప్పండి.
మనకు అలా సార్, మనకు బెంచ్ మార్క్ ఇయలే సార్, డైరెక్ట్ RL వాల్యూ ఇచ్చారు. RL సబ్స్టిట్యూట్
బెంచ్ మార్క్ ఇయలే, బట్ ఏమి ఇచ్చిండు, ఆర్ఎల్ ఆఫ్ ద ఇన్స్ట్రుమెంట్ స్టేషన్ ఇచ్చిండు కదా. ఇన్స్ట్రుమెంట్ స్టేషన్ అంటే ఎక్కడ ఉంటుంది, గ్రౌండ్ మీద ఉంటుంది. ఓకేనా? ఆ గ్రౌండ్ మీద నుంచి ఇన్స్ట్రుమెంట్ యాక్సెస్ కి హైట్ ఇచ్చింది కదా, అప్పుడు ఈ రెండు యాడ్ చేస్తే మనకి ఏమవుతుంది, ఆర్ఎల్ ఆఫ్ ద ఇన్స్ట్రుమెంట్ యాక్సెస్ అవుతుంది. అంతేనా? ఆర్ఎల్ ఆఫ్ ద ఇన్స్ట్రుమెంట్ యాక్సెస్ ప్లస్ వి వాల్యూయే కదా మనకి ఆర్ఎల్ ఆఫ్ ద ఆబ్జెక్ట్ అయ్యేది. అంతే కదా?
అంతే.
ఇన్స్ట్రుమెంట్ యాక్సెస్ నుంచి మనకు వస్తుంది ఆ వి వాల్యూ. గ్రౌండ్ నుంచి ఇన్స్ట్రుమెంట్ యాక్సెస్ వరకు ఉన్న హైట్ని మనం లెవెలింగ్ స్టాఫ్ పెట్టి తీసుకుంటాం. అప్పుడు మొత్తం యాడ్ చేస్తే మనకి ఎలివేషన్ ఆఫ్ ద ఆబ్జెక్ట్ వస్తుంది. దానికి మనం రెడ్యూస్ లెవెల్ ఆఫ్ బెంచ్ మార్క్ యాడ్ చేస్తే మనకు మొత్తం వస్తుంది అనమాట. ఇక్కడ మీనింగ్ ఏంటంటే బెంచ్ మార్క్ దగ్గరే వాళ్ళు ఇన్స్ట్రుమెంట్ పెట్టారు, దాని మీనింగ్ అది.
ఓకే.
ఓకే, సెకండ్ ప్రాబ్లమ్ ఆల్సో సేమ్ థింగ్. ఓకేనా? బట్ it is 3 degrees 36 minutes vertical angle is here. Okay na? But here angle of depression angle is given. Angle of elevation ichcharu ikkada. In second problem they are given as the angle of depression. Okay na? Solve same thing, like same, we have to calculate the v value, next d value, and next we have to calculate the RL of the object we can calculate. Okay na? And remember that angle of elevation is given, it means that the object station is somehow above the instrument station. Okay na? Angle of depression is given means the object station is lower the instrument station. Okay na? So in that case, to the RL of the instrument axis we have to subtract the v value. అంతే కదా? బెంచ్ మార్క్ ప్లస్ RL height of the instrument will be give the RL of the instrument axis. ఓకేనా? RL of the instrument axis నుంచి మనం టెలిస్కోప్ ని డౌన్ కి స్వింగ్ చేస్తేనే మనకి ఏమొస్తుంది చెప్పండి, యాంగిల్ ఆఫ్ డిప్రెషన్ వస్తుంది. అప్వర్డ్ స్వింగ్ చేస్తే యాంగిల్ ఆఫ్ ఎలివేషన్ విల్ కమ్. ఓకేనా? సో ఇన్ దిస్ కేస్ ద v value to be subtracted from the RL of the instrument axis. ఓకేనా? Only that is the difference for the previous problem and this problem. Remaining all same. Okay na? So do calculate here. First calculate the S value. S is equal top reading minus bottom reading. Okay na? So 2.815 minus 0.785, that is equal to, what is the S value here? .030 meters. S is here. Okay na? So then calculate the three things. What is asking to calculate the elevation of P is asking. And next, distance between B and P he is asking. Okay now. So here instrumentation is B. It's been given as B. Okay now. So do calculate here. We require only three things here. Okay now. So one is the distance between B and P. Next one is the elevation of P. Next one is the RL of P. These three things we have to calculate here. Okay now. So for distance D value we have formula. This is the formula to calculate the D value. And for elevation of P means V. Okay now. So to determine the V, this is the formula here. V is equal to Ks sin 2 theta divided by 2 plus C sin theta. And RL of P means we have formula. RL of P can be calculated from the benchmark plus height of the instrument plus P minus middle reading to be done whenever angle of elevation is given. Okay now. Whenever angle of depression, it means that minus is given. In that case, we have to do minus V. Okay now. So benchmark plus height of the instrument minus V minus middle reading. Okay now. So substitute the values and tell me. E value can always take K value as 100 into S value we have been calculated as 2.030 into cos square theta. What is theta here? Minus 3 degrees 36 minutes. But whenever we are subtracting here, you can take it as 3 degrees 36 minutes. Okay now. So don't here minus is given that they are mentioning that it is the angle of depression. Okay now. So when we are substituting in the formula, we no need to mention whether it is positive or minus. Okay now. So that's why directly you can substitute 3 degrees 36 minutes cos square it is. Plus C value anyhow it is 0. Okay now. So plus 0 into cos 3 degrees 36 minutes will be 0. Okay now. So 0 into so what is the D value here?
202.19. Two not 2.19 meters. That's all. Okay now. And next we have to calculate the V value here. V is equal to Ks into sin 2 theta divided by 2 plus C sin theta. Okay now. So K value is 100 into S value is 2.030 into sin 2 theta divided by 2 has to be sin 2 into theta 3 degrees 36 minutes minutes. It is 3 degrees 36 minutes divided by
2 plus C means anyhow C value is 0. Okay, now so 0 into
12.72.
okay.
$12.72.
P value we are getting, how much we are getting? 12.72.
12.74.
Yeah, 12.72 meters. Correct. And RL of the object, how much we are getting?
84.015.
Benchmark is given as 97.135 plus height of the instrument is given by 1.40 minus V, how much we got? 12.72 minus the middle reading is the 1.800. That is equal
84.015.
84.015 meters is the RL of the object station P. That's all. Okay, now so these are the things we have been calculated. For every problem, we have to calculate these three values in tacheometric survey. That's all. Okay, now. Tell me, all of you understand or know how to solve the problems? The problems will be too much easy. Okay, now, so we have only two formula. One is the formula for D, another is the formula for V. Okay, and then we have to calculate the reduced level of the object.
Sir.
Sorry. Okay, now. Okay.
Okay, sir.
Okay, next, take the one more problem. The problem number 3. Okay, now. So you can read the problem clearly. Then you will understand. Read the problem clearly here. A tachometer was set up at station A and the readings on the vertically held staff at B, the were 2.255, 2.605 and 2.955. The line of sight being at an inclination of 8 degrees 24 minutes. Another observation on the vertical held staff at benchmark gave the readings 1.640, 1.920 and 2.220. The inclination of line of sight being 1 degrees 6 minutes. Okay now. So calculate the horizontal distance between A and B and elevation of B from B if RL of benchmark is 418.685 meters. Okay, so constants of the instrument were 100 and 0.3. Understand, Anna? So actually the additive constant C can be taken as 0.0 only. Okay, but in this case it came as 0.3. Nothing wrong. Okay, now. So if it is not given, directly you can take as 0. If it is given, you can take it as 0.3 or something. Okay, now. C value is given as 0.3 here, and anyhow multiplying constant K value is given as 100. Okay, now. This is the problem they have been given. See that, first see here, tachometer is the instrument which is set up at station A. Okay, and it means A is the instrument station. Okay, now, and a leveling staff is kept at B. It means B is the instrument station. Sorry, B is the object station or staff station. Okay, now. So, and the staff readings were given, top reading, middle reading, and bottom reading were given, and angle of elevation is given from A to B, 8 degrees 24 minutes is the angle of elevation is given. Okay, now, and this is the readings taken from the instrument station to the object. Okay, now, and next one more observation, they have been taken to the benchmark, because always the benchmark is the most important reading, because we have to take the height of the instrument. Okay, it means that the RL of the instrument axis is the most important thing. Okay, so and remember that always whenever we do take RL of the instrument axis. Okay, so it means that in that case we keep the leveling staff at benchmark, and then we take the backside or we take the reading. Okay, now, but here the, and remember that whenever we do take the reading at benchmark, the instrument axis should be set 0 0. It should be set 0 degrees 0 minutes. Okay, now, but in this case they did a mistake that the instrument whenever they are taking reading at benchmark. Okay, now, so the instrument axis, sorry, the instrument is showing an inclination angle as 1 degree 6 minutes. Okay, now, so this is the wrong case. Okay, now, so that's why the additive constant came as 0.3. If they set as 0 degree 0 minutes, and if they take the accurate readings, it might come 0. Okay, now, but anyhow the inclination is given as the 1 degree 6 minutes. Okay, now, so in this case we have to calculate the height of the object station B. We have to calculate the distance between A and B, and also we have to calculate the RL of station B. Okay, now, so these three things we have to calculate here. Okay, now, and the, in this case you can see here the benchmark, whenever we do take the back set or whenever we do take the benchmark reading, in that case the central reading can be height of the instrument axis. Okay, now in this case the central reading or height of the instrument can be 1.920 whenever we set 0 degree 0 minutes. Okay, now, but here it is set as 1 degree 6 minutes. Okay, now, so that's why we have to calculate the V value here first. Okay, now, so then that V value will be the height of the instrument here. Okay, now, so first you do, it means that in these two cases were given, instrument station is A, object station is B, and one more thing is taken as benchmark. Okay, now, so I think better you draw the table here. Okay, now you take one table here from the given readings, then you will understand. Okay, now instrument 8, in all the cases instrument is at A and A. Okay, now, and what is the next column here? Height of okay, see. It may be little late because it is online class now. Okay, now, so you take this staff point. First one is the staff at benchmark, and next one is the staff at staff station B. Okay, now, so when they bisected to benchmark, the vertical angle is plus 1 degree 6 minutes, and when they bisected to B, the vertical angle is plus 8 degrees 24 minutes. Okay, now, and staff readings, in case of benchmark, 3 readings were given. You can see here. And staff readings towards B, 3 readings were given here. You can see here. And RL of the instrument station is given as RL of benchmark they have been given here. Okay now, RL of benchmark for both the cases is same. Okay now, delete the column. Okay, so this is the table that they have been given here. Instrument at A, in both the cases, first they have been bisected to benchmark. So at that time vertical angle is there, staff readings were there, RL of benchmark is given. Okay now, B is the object station. Okay now. So first case, first of all we have to calculate the height of the instrument axis. It means RL of the instrument axis we have to determine. Okay now. So see here. Okay guys, I think you understand. Okay now. We will continue next class the same problem. Two cases will be there. One is the observations to benchmark, and next one is the observations to station B. Okay now. In this case, we no need to calculate the D value. In this case, directly we can calculate the V value. What is V here? Okay now. And in this case, we have to calculate the, in B case, we have to calculate the D value, and also we have to calculate the V value. Also we have to calculate the RL of, that's all. Okay now. In this case, the V value will be the height of the instrument. Understand now? So the V value will be the height of the instrument, or yeah, HI, height of the instrument. Understand? So these are the, this is the thing it is given here. These are the values we have to calculate. You can calculate before next class. Okay now. In next class I will explain you this same problem.
సార్ డివి వాల్యూ వచ్చినాయి సార్ రెండింటికి అయితే ఏం చేయాలి సార్ ఇప్పుడు
V వాల్యూ వచ్చిందా బెంచ్ మార్క్ కి? ఆ B వాల్యూ నీకు హైట్ ఆఫ్ ద ఇన్స్ట్రుమెంట్ అవుతుంది. ఎంత వచ్చింది? D వాల్యూ V
ఫస్ట్
వాల్యూ
దానికి
వచ్చింది కదా. అబ్జర్వేషన్స్
10.41
టు, ఓకే ఓకే, అబ్జర్వేషన్స్ టు B నీకు D వాల్యూ V వాల్యూ వచ్చినాయా?
వచ్చినాయి సార్.
ఆ రెడ్యూస్డ్ లెవెల్ ఫైండ్ అవుట్ చేయండి.
ఓకే రెండింటికి ఫైండ్ చేసినాక ఏం చేయాలి సార్?
అంతే, ప్రాబ్లం అయిపోతుంది.
ఓకే సార్.
అంతే, ఆ వాల్యూస్ ఫైండ్ అవుట్ చేయాలి అంతే.
సరే సార్.
You can see these are the attendance sheet. Okay now. Guys, you can leave and you can join for next class. You can leave and you can join for next class. Okay now, only 48 students were present today. 1, 2, 3, 1, 2, 3, 4 absent, 3 absent, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 absent, 18 present. 21 series 38 1 2. Okay, these are present today.